Hello, physics students. This is Mayo Tutors here with you another set of physics questions, specifically energy-related questions for grade 12 students. So here we have is two questions. So this is in addition to my part 1 video. Here we have a friction type question / some understanding about energy and how it can be related with force applied, force of friction, different forces that are basically in relation to energy. So here I will start off with question 27. A 23 kilogram block slides 18 meters on level ground before coming to rest. If 430 joules of work are done by friction, calculate the coefficient of friction between the block and the ground. So this is basically a question to check your understanding of how you can surround yourself with work and energy, which is used arbitrarily between each other, and its relation to force. So as we know that work is related to force by multiplying force applied, multiplying by the distance across, so the change in distance, right? We can actually change this to an equation to represent force of friction multiplied by its distance. Here, we also can basically rewrite this equation to having force of friction as our left side equal to work divided by distance. So if we were able to plug in these numbers, we know that work here is 430 joules. So 430 joules over the distance across. And since we know this is sliding on level ground in one direction, we can write that it's 18 meters, right? Remember to always write your units. It's just easier for converting later. So if we were to calculate this, type this into my calculator, we get 23.889 newtons. Remember, units are important. So we got the force of friction, but we need the coefficient of friction between the block and the ground. So at least we got the force of friction, because as we know that force of friction is equal to Fn. We're considering that mu has the coefficient of friction. We know this is the normal force. And we know this is the friction force or force of friction. Right? So we are able to get the FF, but we still need Fn to determine mu, right? So that's our next objective. To get Fn, we can look at our vertical axis, so our y-plane, right? We know that the sum of forces within the y direction must equal to 0. Why? It's because it is on a flat surface, like a level ground, and it isn't moving at all within the y direction. So we can safely assume or state that forces in the y direction, the sum of the forces equals 0. If we were to break this down into components, we have Fn minus mg, right? This mg is basically representing force of gravity right here, right? We know that has to equal to 0. Maybe this is easier to understand within a free body diagram. Free body diagrams are usually very helpful when visualizing the problem. So we see that this is sliding 18 meters on a level ground before coming to rest, right? So we see that it is not moving anywhere in the y direction, right? We know that there is an FF force, force of friction, assuming that it's going in this direction. So let's say this is plus y plus x, right? Assuming that it's going in this direction, we have a force of friction. There is no necessarily force of applied because it doesn't mention that the force is continuously being pushed, or the object. We also have the Fn and Fg force here. And this is the sum that I was talking about, that it equals to 0, right? Perfect. Okay, so let's take this equation and keep going with it. So we know that Fn has to equal mg, right? And if we were to calculate mg, we know the object is 23 kilograms. We are multiplying it by 9.8 meters per second square, right? We get a total, if I punch into my calculator, 225.4 newtons. Perfect. So now we have the Fn. We also have the Ff. Now we can solve for mu. So, final statement, we can rearrange the equation to get mu equals Ff divided by Fn, right? If we were to plug in these numbers, force of friction divided by force of normal, 23.889 newtons divided by 225.4 newtons. Then we have that the force of friction, the coefficient of friction, between the object and the surface is 0.10598. It is also important to notice that the mu that we were solving for is friction, the coefficient of friction, kinetic, because the object is moving. The other one would be the static coefficient of friction. And there you have it. So this is answering question 27 in physics energy question problems. Thank you for watching.